Good morning. Namaste to all dear students. Myself, JVN Dr. Priya Gothwal, Faculty of FEM in Department of Chemistry. Before I discussed on alkanes, and today I am going to discuss cycloalkanes, which is the next category through the alkanes. Cycloalkanes. Before, we categorized hydrocarbons to the aliphatic or alicyclics. The cycloalkanes remain in a category of alicyclic compounds of hydrocarbon. As we know that hydrocarbon is a carbon containing carbon and compounds containing carbon and hydrogen only. So we discuss a cycloalkanes in this slide in this video. Cycloalkanes have molecular formula CnH2n and contain carbon atoms arranged in a ring. Simple cycloalkanes are named by adding the prefix cyclo to the name of the acyclic alkanes having the same number of carbons. Here we can see numerous cycloalkanes in the first category of this, which is known as cyclopropane, having a molecular formula is C3H6. Next, cyclobutane, the carbon containing number 4 and hydrogen is 8, which is known, the molecular formula is C4H8 in a cyclic form, which is known as cyclobutane. Here we can also see the 5-membered carbon atom containing cyclo compound, which is known as cyclopentane, having a molecular formula C5H10. In cyclohexane, the carbon atom containing C6H12 in a cyclic manner, which is known as cyclohexane. We can see here that all of the compounds are in cyclic form, and which is the alicyclic, which is the aliphatic category, which is known as a cyclo compounds in the organic chemistry. Here we can next discuss to this category. It is a nomenclature system of this kind of hydrocarbon, which is known as cycloalkanes. The nomenclature system, according to IUPAC, International Union of Pure and Applied Chemistry, revealed that the name of every organic molecule has 3 parts. The number 1, the parent name indicate the number of carbons in the longest continuous chain. First thing क्या है हमारी? The parent name, which is indicate to the number of carbon atoms in a longest continuous chain. The second one is the suffix. The suffix indicate what functional group is present. Many kind of functional group is found in the organic compounds. And the third, the prefix tells us the identity, location, and the number of substituents attached to the carbon atoms. Those species which is prefixes to the main carbon containing compounds. So we discuss here prefix, what and where are the substituents. Okay, plus parent chain. Parent chain belong to the longest carbon chain, and plus suffix. Suffix which is denoted to the functional group, that what kind of functional group attached to the longest carbon chain. So this is described through some examples. Firstly, carbon substituents bonded to a long carbon chain are called alkyl groups. Okay, an alkyl group is formed by removing one hydrogen from an parent alkane. If a hydrogen atom is removed from the carbon atom containing parent chain, which is denoted by a alkyl group. To name an alkyl group, change the ane, adding the parent alkane to al. Thus, methane becomes methyl, which is denoted by CH3 group, and ethane becomes ethyl, which is denoted by ethyl group. The naming 3 or 4 carbon alkyl group is more complicated because the parent hydrocarbons have more than one type of hydrogen atom. For example, propane has both 1 degree and 2 degree hydrogen atoms, and removal of each of these hydrogen atoms form a different alkyl group with a different name, propyl or isopropyl. Here we can see the numerous examples in this category. First of all, some example like propane, CH3, CH2, CH3. Here we can say the 1 degree hydrogens are present in this kind of compound, and also containing a 2 degree hydrogen, which is belong to the 2 degree carbon atom. In this, if we remove a 1 degree hydrogen, two possibilities are here. Two possibilities are here, that is removal of 1 degree hydrogen. Here, the propyl group is generated, which is denoted to CH3, CH2, CH2, along with a valency, right? And if the removal of 2 degree hydrogen, we get a isopropyl group because the hydrogen is removed from the secondary carbon, which is known as 2 degree carbon. We get isopropyl group, a middle carbon atom free from its hydrogen valency. Here, next, we can see that the other examples of this kind of category, we are nomenclate to other compounds. First, find the parent carbon chain and add the suffix. Likewise, first of all, two possibilities are generated this time at the time of the IUPAC nomenclature system. First of all, we must have to choose correct longest chain. Having a number of carbon atom is maximum. Like we can see here, the first possibility is 1, 2, 3, 4, 5, 6, 7, 8. Here, the longest carbon chain of the 8 carbons, which is denoted to octane, oct plus ane. Ane is suffix denoted to the alkane category, and also having a substituents present in this 8 carbons longest chain, which is methyl substituent and ethyl substituent. The second incorrect possibility also generated in our mind, like if we numbering to the carbon chain, likewise 1, 2, 3, 4, 5, 6, 7, 8. Here, if we count here 1, 2, 3, 4, 5, 6, this is the only 7 atom in the longest chain. This is the incorrect numbering. Okay, so first of all, find the parent carbon chain and add the suffix. After that, note that it does not matter if the chain is straight or it bent. The chain may be straight or bent in process of the nomenclature system. Here we understand also another example through the here This alkane is also having a number of 8 carbon in the longest chain. So one molecule is numbered through the different ways. This is a criteria of the IUPAC nomenclature system. In next, we can see the also note that if there are two chains of equal length, okay, pick the chain with more substituent. In the following example, two different chains in the same alkane have 7 carbon atoms. We circle the longest continuous chain as shown in the diagram on the left, since this result in the greater number of substituents. So having an example, having two different longest carbon chain of the same length, like through this example, in this example, the same 7 atom in the longest chain and having a 2 substituent, which is that is more substituent present in this kind of numbering, which is the correct sequence of the numbering. And the next, we can see the 7 atoms in the longest chain, only one substituent, which is known as isopropyl substituent. This is an incorrect numbering of the carbon chain. So firstly, we selected a longest carbon chain. After, we can see that the 2 or more substituent are present in the longest carbon chain. Second condition is the number of the atom in the carbon chain to give the first substituent the lowest number. Like that, here start numbering 1, 2, 3, 4, 5, 6, 7, 8. It is a octane hydrocarbon, okay, having 8 carbon in the longest carbon chain. Now we start numbering here. If we start from here, first, second, 1 and 2, the substituent going to be second and the other substituent going to be fifth number, other to the sixth number. Okay, we can also see, we compare that the incorrect numbering, how can it can be measured from us, like if we numbered from here 1, 2, 3, so the substituent is lying on the third number of the carbon atom, which is the far from the first one. So the correct sequence is the substituent having a lowest number to the longest carbon chain. If the first substituent is the same distance from both ends, number of the chain to give the second substituent the lower number. So we have an example giving a lower number to the second substituent. If two or more substituents are present in the longest carbon chain, the second substituent must have to lowest number of the substituent along the chain. For example, if we numbering from the left to right, the 1, 2, 3, 4, 5. Okay, the CH3 group 8, this methyl group 8, C2, C3, and C5. The second substituent has a lower number, which is the correct sequence of the numbering. And if we numbered from right to left, then the CH3 group 8, C2, C4, and C5. C4 has a higher number of the second substituted group, which is known as methyl group, having a higher number. So this this progress of the numbering, which is the countable in incorrect numbering of the compounds. So we can see that the numbering of the second substituent must be the lower number. When Numbering a carbon chain result in the same numbers from either end of the chain. Assign the lower number alphabetically to the first substituent. Yes. For example, if we have two different groups equidistant from the ends, what? Two different groups equidistant from the ends. If we numbered from left to right, okay, so the two kind of group, which is ethyl and methyl. Ethyl at C3 position, methyl at C5 position. Earlier letter, lower number, which is the correct sequence of the numbering of according to the IUPAC nomenclature system. In the second case, numbering from right to left, that is the methyl at C3 position and the ethyl at C5 position. So the alphabetically, which is the wrong decision to make numbering. So the correct sequence is numbering, the correct sequence of numbering from left to right, having ethyl at C3 and methyl at C5 position of the longest carbon chain containing compounds, which is alkane. In next slide, we discuss name and number of the substituent. Name and number of the substituent. The name the substituent as alkyl groups. Every carbon belongs to either the longest chain or a substituent, not the bottom. Each substituent needs its own number. If two or more identical substituents are bonded to the longest chain, use prefixes to indicate how many. Di for 2 groups, tri for 3 groups, tetra for 4 groups, penta for 5 groups, hexa for 6 group, hepta for 7th group, octa for 8 group, and so on. Okay. This kind of example we can see here that the first we choose a longest carbon chain according to the IUPAC nomenclature system. Here 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 number of carbon atoms chain having a 2 or more than substituents present on the chain. Second, which is the substituent having a lowest number to the chain. Likewise, from left to right, first, second, methyl 8 C2 position, methyl 8 C6 position, and ethyl 8 C5 position. This molecule has 3 substituents bonded to the longest carbon chain. So we can say that the numbering of the substituent is the most important thing in the IUPAC nomenclature system. If the fourth condition is combine substituent name and numbers plus parent and suffix. In this, precede the name of the parent by the names of the substituents. Alphabetize the names of the substituent, ignoring all prefixes except iso as an isopropyl and isobutyl. These are two conditions in this kind of nomenclature system. Precede the name of each substituent by the number that indicate its location. Separate numbers by commas and separate numbers from letters by hyphens. The name of alkane is a single word with no space after hyphens and commas. Like that, in this type of example, we identify the locant, identify all the pieces of a compound using step 1, 2, 3. We discussed earlier. In this kind of example, having a number of 8 carbon chain present, which is known as octane. the numbering is left to right. The C2 methyl 8 C2 position, ethyl 8 C5 position, and methyl is also at C6 position. So 2 and 6 position containing exactly the similar substituent group, which is known as methyl group, 2 or more. 2 substituent like dia. So we can number it here 2,6 dash dimethyl group. Okay, each methyl group need its own number. Here, also a second possibility is here generated like that. Then put the piece of the name together. If 5-ethyl dash 2,6-dimethyl alphabetize E for ethyl, then M for methyl, plus oct. Oct denoted to the number of carbon atoms. 8 carbon atoms present in the longest carbon chain. Plus ane. Ane is a suffix which is denoted to the functional group like the alk plus ane, alkane, which is denoted by a single bonded and sigma bonded in alkanes. So the answer is, so the nomenclature of this kind of alkane is 5-ethyl 2,6-dimethyl octane. So the cycloalkanes are named by using similar rules. Okay, but the prefix cyclo immediately precedes the name of the parent. Likewise, the prefix what and where are the substituents, plus cyclo is denoted to a ring is present. Parent, how many carbons are in a ring, and suffix, what is the functional group of the compound. So this is the procedure for the nomenclature of the IUPAC system of the alkanes, which is also for also to the further cycloalkanes. Right? Find the parent cycloalkanes through this example. This is a cyclic ring of number of 6 carbon atom having a 2 substituents, which is denoted by methyl and ethyl. So the carbon atom is 6. So the nomenclature system is methyl, meth, and eth, ethyl, and methyl. So the 1, 2, 3 ethyl, 1 ethyl, 3 methyl cyclohexane. It is given. It's a nomenclature system. The second one is name and number of the substituents. No number is needed to indicate the location of a single substituent, right? Likewise, methyl cyclohexane, here tertiary butyl cyclopentane. So 4 rings with more than one substituent being numbering at one substituent and proceed around the ring to give the second substituent the lowest number. So here the numbering is clockwise according to the rule like CS3, 8, C1 and C3. The second substituent has the lowest number. So the correct nomenclature is 1,3-dimethyl cyclohexane. And the second phenomena is also occur, which is the wrong, but we can understand from this example. The numbering is if counterclockwise, which is known as anti-clockwise system. So the CS3 group at C1 and C5. So incorrect numbering is 1,5-dimethyl cyclohexane. So we can see that how can affect the numbering of the substituent in a compound. If with the 2 different substituents, number the ring to assign the lower number to the substituent alphabetically, being numbering at the ethyl group. Here, ethyl group at C1 and methyl group at C3 position. So earlier letter is the lower number according to the alphabetically rule of the nomenclature system. So the correct numbering is 1, ethyl 3-methyl cyclohexane. The second possibility is, which is incorrect, but we can understand by this example, being numbering at the methyl group 8 C1 position and ethyl group 8 C3 position. The incorrect numbering is 3-ethyl 1-methyl cyclohexane. Note the special case of an alkane composed of both a ring and a long chain. If the number of carbon atom in the ring is greater than or equal to the number of carbons in the longest chain, the compound is named as cycloalkanes. So this is a system of the nomenclature of the organic compounds, and some of the fewer examples of this category, like two contrasting examples naming compound containing both a ring and a long chain of carbon atoms. Here, we can see more carbons in the ring. If having more carbons in the ring, like 4 carbons in the chain, a butyl group, which is joined by a cyclic group, which is known as cyclohexane, 6 carbons in a ring, which is prefixes as cyclohexanes. Name is cyclohexane with a substituent. So the final IUPAC nomenclature is butyl cyclohexane. In the next example, more carbons in the ring, more carbons in the chain, 6 carbons in the chain, a hexane, 4 carbons in the ring is known as cyclobutyl group. Name as hexane with a substituent, which is known as 1-cyclobutyl hexane according to the IUPAC nomenclature system. Here we also discuss some other examples in this category, which is known as ethyl cyclobutane, 1-secondary butyl 3-methyl cyclohexane. The number is needed with only one substituent. Okay. And other example is 1,2-dimethyl cyclohexane, other 1,2,4-trimethyl cyclopentane, etc. So the nomenclature of the common names, some organic compounds are identified using common names. They do not follow the IUPAC system or the nomenclature. So this section is continued in the other video. Till then, thank you so much. Have a nice day. Namaste.